The trapezoid rule. Together with Simpson's rule, it's one of the most commonly used rules for approximating areas under curves. If you have a curve where you want to find the area under it between A and B, you can create a trapezoid and find the area of that. To find the area of a trapezoid, we find the distance between the two parallel lines M and N. The distance we will call h. We divide that distance by 2 and multiply it by the sum of the length of the two sides. Now you can skew the parallel lines and the area of the trapezoid will be the same. That's why we can use trapezoids to approximate areas under curves. If we rotate our trapezoid and put it under a function in a coordinate system, we see that the height becomes the length along the x-axis. Let's call the points on the x-axis A and B. We can see that the distance h is equal to b minus a. Let's update our formula. We can see that the length of m is equal to the function value at the value of f of a, and for n it's equal to f of b. We replace m and n with f of a and f of b in our formula. You can see that the trapezoid makes a pretty good approximation of the area under the curve. But since this is now an approximation, we have to change the equal sign to the approximate sign. The trapezoid is a good representation of the area under the curve in this case, but what if the curve was a parabola? It would then be a really bad representation. But we can fix this by just adding more trapezoids. We will call the points of the parallel lines between A and B for x1, x2, and x3. This gives us 4 trapezoids to calculate the area of. Let's start with the first one. The length of the first parallel line is f of a, but the length of the second parallel line is f of x1. The last thing we need is the height or length from a to x1. We find this by calculating b minus a, and then dividing it by the amount of trapezoids that we have, which is 4. We will represent this value by n. So the formula for the area of the first trapezoid is h divided by 2 and multiplied with f of a plus f of x1. Just have to do the same for the rest of the trapezoids and add them. As you can see, we have a common factor here, and all the middle values gets added 2 times. So we can write it like this. And there you have the trapezoid rule. We could write it more generally like this. But why would you use this rule when you can just use normal integrals and get the exact answer? Number 1, because some functions don't have an antiderivative, like the integral of e to the x squared and the integral of 1 over ln x. And the second reason is, sometimes you have a measurement and no function, like for example the area of a lake, and you can then use the trapezoid rule to approximate the area of that lake.